Today, I would like to present my topic titled Automatic Charging Using Solar Photovoltaic for Aeration Alarm System. So, what is this project about? This project focuses on developing an automated solar powered aeration system with an integrated alarm for aquaculture. Mm. The system charges autonomously via a solar photovoltaic module connected to a 12-volt rechargeable battery, enabling continuous operation even during low light or nighttime. An Arduino microcontroller, specifically the ESP8266 module, manages the power distribution, activates the air pump, and monitors real-time performance. Water level pressure sensor further improves the system functionality by monitoring air pressure and ensuring effective oxygenation. Initial results shows consistent battery charging and aeration performance. Aeration performance, even with limited sunlight, reduce operational costs and reliance on non-renewable energy. The alarm system allows prompt, prompt action in the event of a malfunction, adding a critical layer of safety. This sustainable automated aeration solution is particularly beneficial for rural off-grid aquaculture, enhancing efficiency, reliability, and environmental sustainability. So, as you can see, my figure one is my block diagram. So it's pretty simple. The main microcontroller is the ESP8266. Okay. So ESP8266. So the solar panel will be connected to the charge controller, which will then be connected to the battery, which will then supply power to the microcontroller. Then the microcontroller will also be connected to a airflow sensor as the only sensor input for the whole system. Then as the airflow sensor reading changes, the air pump will be controlled depending on the type of change. For example, if airflow detects low airflow, the air pump will turn on. If it detects high, the air pump will turn off. Then similarly, the ASP will be integrated with the Blink IoT, which will send a notification to the user's phone every time the reading changes. So this is figure two is my flow chart. It starts with solar panel receiving energy, which will be transmitted to the charge controller. Then we will go to the battery. First, we have to check whether the battery is functioning or not. If it's not, it will switch to the external power source. If it is, it will power the alarm, the whole system technically, not only the alarm system, which then will activate the airflow sensor, and we will also check whether the sensor is detecting any airflow. If it is, operation continues as intended. If it's not, the alarm system will be activated, which will then send a notification through Blink, and and the process will repeat until the power is cut off or the user stops the system. Then next, we have my required results. In table one, you can see my solar charging results. I've tested the solar charger and I've collected the data that the mono voltage, so I just set the charge controller float voltage to 13 volts. So since the weather conditions are not that sunny bright, so the voltage output voltage, the voltage the solar charger could display was not that high, but still high, but then not as high as float voltage. Then this figure 4 shows my Blink mobile dashboard. Figure 3 shows the graph from the table 1. Figure 5 shows the notification, examples of the notifications I got from the system running. So in conclusion, the project aims to develop an automated solar charge aeration alarm system The solar charging successfully powered the battery, delivering the needed output. The battery, depending on the condition, if it's a sunny day, it will charge in 2 hours. If it's not a sunny day, like cloudy or raining, it will take 4 to 5 hours estimated. The app pump will turn on based on the readings of the pressure sensor, as aforementioned just now. So the commercialization potential is that I estimate it will have a high demand in the market of rural farmers, especially for those in areas far away from conventional power sources. To widen the marketing range and scope, the system will be made as cheap as possible to cater to the more financially challenged farmers to give them a better chance in the fish farming industry.
Hello, good evening to my panels. Today I would like to present my project. So this is my, as you can see, the setup is it starts with a solar panel. It will go through the charge controller, and after charge controller, it will go to the battery. After battery, it will power the whole system, which is the sensor and the air pump. But But today, while testing, the solar charger gave some problems, so we won't be able to use the solar. So we will use the external source as backup. So and source. So as you can see, after I turn on the power source, it powers the relay to turn on the air pump. Then in link IoT setup, this is for to pressure sensor, and this is supposedly to indicate whether the air pump is on or not. But the programming is not really working right now, so we will just let it turn off. Then okay, so supposedly the sensor supposed to detect the airflow in the aquarium, but due to some manufacturing errors and some faultiness in the sensor, it can only stick to one value. So that's why the air pump is going on, and then since the sensor can only give back one value, so I can only get one notification, which is the low airflow. Okay. Okay. So okay, thank you.